Welcome to our Geometry Week 9 recording. This is week 9 that we are in, and it's also the week of October 11th. So we're going to jump right in and make sure that you guys have your math notebook out and you're ready to take good notes that will help you when you go to do the graded assignments this week. I am going to start with a warm-up problem, just like normal, where we are going to be pulling from what we've actually learned the last 2 weeks. So during the last 2 weeks, we have been looking at how we can prove two triangles are congruent. And we know for two triangles to be congruent, they have to have all sets of corresponding sides need to be congruent, and all sets of corresponding angles need to be congruent. And lucky for us, we learned that there's some shortcuts, some postulates that we've learned that allows us to not have to prove all of those things are true. We don't have to prove all three sets of corresponding sides are congruent, and we don't have to prove that all sets of corresponding angles are congruent. We've got the shortcuts where we can use the side postulate, the side angle side postulate, the angle side angle postulate, and the angle side postulate. And we know that the order is important of where the sides and angles are placed. So looking at these two these are two triangles, can we prove that those two triangles are congruent? Do we have enough information to prove that these two triangles are congruent? And if we can prove these triangles are congruent, which postulate can we use? Which one of these postulates can we use? So I'm going to give you a moment to think about that. I do want you to answer this on your own in your math notebook. So go ahead and click pause now and answer this question. And then when you're ready to check your work with mine, go ahead and click play. All right, so we've got a bunch of ticks and arcs here, which are very helpful for us. I'm looking here and I see that this triangle, this side has 2 ticks, and on the other triangle, this side has 2 ticks. That lets us know that those two sides are congruent. And then we've got this side here. It looks like our hypotenuse is congruent with the hypotenuse on the other triangle because they both have 1 tick. And then we've got a set of congruent angles. We've got 1 arc here and 1 arc here, which lets us know that those angles are congruent. So what do we have? We've got an angle, a side, and a side. Angle, a side, and a side. Or side, side, and an angle. So we can look at it in either order. And what happens when we have a bad word spelled? Remember, I've told you about this in the past. If we end up with the given information, come up with this naughty word, we know that that's not enough information. That is not in our postulates. So in this case, we do not have enough information, and we cannot prove that those two triangles are congruent. We cannot prove that the triangles are congruent because we don't have the correct ordering of congruent angles and sides. So if ever you have spelled a bad word, you know that that is not enough information to prove that the triangles are congruent. I'm going to go on to the next slide and chat about what we are doing this week. So we do have a short week this week. We don't have school on Friday, but remember, Schoology is always available to you. So if you do want to work on Friday, you are more than welcome to. You can get caught up with work, get ahead, redo assignments. Just know I won't be available, but Schoology is there and you can be working. So we will only be completing 2 sessions this week. Session 7 is about this acronym here, CPCTC, which stands for Corresponding Parts of Congruent Triangles Are Congruent. And we'll chat about that in just a moment. And then we're going to do session 8, where we're going to look at the patterns in isosceles and equilateral triangles. So let's jump right in. I think I chatted a little bit about this. What needs to be true for two triangles to be congruent? All corresponding angles need to be congruent, and all corresponding sides need to be congruent. And lucky for us, we've got that shortcut of several postulates that help us prove that triangles are congruent, where we only need to find 3 sets of corresponding sides or angles. We can use the angle side angle, the side side side, the side angle side, and angle angle side. I think I got all those right. Yep, angle angle side. So we can use one of these postulates to kind of cut some corners to prove that 2 triangles are congruent. So we've worked the past 2 weeks on just proving that 2 triangles are congruent. Well, this week we're going to take it a step further, and we're going to add to our bag of tricks the CPCTC postulate. And what that acronym is you see it takes the first letter right here. Corresponding parts of congruent triangles are congruent. So what does that mean? What does that mean? What that means is that if we're able to prove that 2 triangles are congruent, then we know if we've proved 2 triangles are congruent, then we know that all corresponding parts of each triangle must be equal. So what do I mean when I say corresponding parts? What do I mean when I say corresponding parts of a triangle? Right here, what do I mean when I say we know that all corresponding parts must be equal? What parts am I talking about? I am talking about the angles and sides of our triangles. The parts are referring to, when we say parts here, that's referring to the angles and the sides of our triangles. So once we prove that 2 triangles are congruent using maybe the side angle side theorem or the postulate, well then after we've proved those 2 triangles are congruent, then we know that the other 2 sets of corresponding angles are also congruent. So let's take a look here at an example of what I mean. So here are 2 triangles. We've got triangle ABC, and triangle CDE. Can we prove that segment AB is congruent to segment DE? So let's look at that. So can we prove that segment AB is congruent to DE? So let's find those segments. So we want to know if we can prove that this segment here is congruent to this segment. So can we do that right away off the bat, just like this? No, we can't. There's no ticks. Notice there's no ticks in those sides, so we can never assume anything in geometry. Remember, that's the first rule. You can never assume anything. We always have to actually prove. We have to go step by step and prove and back up our statements. So because we have no ticks in those sides, we can't assume those sides are congruent. But what we can do is we can look to see if we can prove those triangles are congruent. So our first step is, can we prove that triangle ABC is congruent to triangle CDE? Can we prove that? So let's look and see if we can. ABC, it would actually be ABC, ECD is the correct way to label that. ECD. So it matches up with the other triangle. Can we prove that those 2 triangles are congruent? So what do we know? We know that, I'm going to get rid of these. We've got a bunch of ticks here, so we know we've got 2 sets of corresponding sides. Do we have any other piece? Remember, we need 3 pieces. We need 3 pieces: side, 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 angle, side, angle, side, angle, side, angle. So we only have 2 sides here. Is there any set of information, additional information that we know is true about any of the angles or sides? We do. So here we've got these 2 angles. Even though these angles are not marked with an arc, we know they're congruent because they're vertical angles. And remember, vertical angles will always be congruent. We learned that back in Unit 1. So now what can we use to prove that these triangles are congruent? We can use the side angle side postulate. So now that we have used the side angle side postulate, we can state that, in fact, triangle ABC is congruent to triangle ECD. So now, since we've proved that these two triangles are congruent, now using the CP-CTC theorem postulate, we know that congruent or corresponding parts of congruent triangles are congruent. So using the CP-CTC postulate, we are able to state that, in fact, segment AB is congruent to segment DE. Because we know that when we have congruent triangles, that every corresponding side and every corresponding angle is going to be congruent. But before we can get there, we had to prove that the triangles were in fact congruent. So we did that. We proved the triangles were congruent using a side angle side postulate. And now we're able to say that side AB is congruent to segment DE using the CP-CTC postulate. All right, I'm going to move on now to the next slide. So go ahead and click pause if you need more time to take good notes. All right, and now moving on to, this is, I believe, session 8, unit 2, session 8 coming from. Unit 2, session 8 is about isosceles triangles and equilateral triangles. And I just wanted to focus more on the isosceles triangles property. I'm going to leave the rest to you to learn in Schoology this week. But let's look at the properties and the patterns that occur with isosceles triangles. So remember, we've learned that isosceles triangles are triangles that have two congruent legs. So two legs are congruent. And a pretty cool pattern that occurs is opposite of our two congruent legs, our base angles are going to be the same. So opposite of our two congruent legs, the base angles will be the same. These two base angles down here are going to be congruent. And that's why they're both in red. And then the third angle up at the top is going to be different. So the angle up here in blue is going to be different. The angles opposite the congruent legs will be congruent. So let's use those properties and solve for a problem where we need to solve for x. So we're going to use the properties of isosceles triangles and those patterns we just learned about. It says solve for x in the figure below. So first of all, we've got two ticks on these legs here. What does that tell us about what type of triangle this is? It is an isosceles triangle. We have two congruent legs. So what do we know about the angles opposite of our congruent legs? What do we know about these two angles that are opposite? We know that those angles are going to be congruent. You got it. We know angle R is going to be congruent to angle S. So we can set up an equation here. We know that angle R is going to be equal to or congruent to angle S. So let's now substitute in our given values for those. We're not given just a straight up number, we're given an equation, and we can set those equations equal to one another. Now we've got a nice algebraic equation where we can solve for x. So to solve for x, I'm simply going to subtract x on both sides, and then we get 30 equals x. Pretty easy, pretty easy. So remember that I only solved for x. Now I noticed a lot of you on the Unit 1 test, there was a couple of you who missed problems because the question asked you to go further and say find the measure of angle S. And some of you stopped and only solved for x, and you forgot to find the measure of whatever they were asking for. So please make sure you are reading the question carefully and answering all parts of the question. So if we want to find the measure of angle S, we know angle S is represented by 2x, And we know that x, we just solved, whoops, and it's 30. So we're going to take 2 times 30 and we would get 60 degrees. We would get 60 degrees. All right, I'm going to go on to the next slide. So if you need more time, go ahead and click pause so that you can take good notes here. I am going to move on to the last question we're going to do together. And this actually comes straight from your graded assignment that you're going to work on this week. So if you were wise, you would make sure you're taking good notes so that when you get to this question on your Unit 2 Session 8 assignment this week, you have something to look back to in your notes to complete the problem, because we're going to do it right here, right now together. So here we've got a diagram. We've got this plane flying in the sky. We've got the tower here, and we've gotten some information that is labeled for us already. And what we need to do is we need to find the length of segment BT. We need to find the length of segment BT. And we know that line AC is parallel to the ground. So that's a clue. So how can we find the length of BT of this segment here? So take a look and see if you might be able to figure that out. And again, here's your clue. You've got 2 sets of parallel lines and AT is a transversal. So is there anything that we know that we learned about transversals? There is some stuff. So let's fill in some angles here and see if we can figure out what type of triangle this is based on the angles. So if we know from here to here is 80 degrees, that's what this marks here. From here to here is 80 degrees. From here to here is 40 degrees. So what must be the angle from there to there? It must also be 40 degrees. So let's go ahead and put that in there, 40 degrees. What do we know about parallel lines and transversals? Is there something that we can pick out from here? So think about the angle pairs that we learned about when we have a set of parallel lines and then a transversal. So trying to highlight that so you guys can see that. So I'm looking and I see that we are given this angle here as 40 degrees. What would this angle have to be up here? And what type of angle pair is that? So these are alternating interior angles. And what do we know about alternate interior angles? They are congruent. So I know that the angle up here must also be 40 degrees. So now we know that this angle is 40 degrees and we know that this angle is 40 degrees. So what does that tell us about what type of triangle we have? So I'm going to get rid of some of our highlighting so that I can highlight just the triangle here. And we can focus on that triangle. Let's see here. So we've got, this is a triangle right here. We've got 2 sets of congruent angles. So we know that it must be an isosceles triangle. We also know that when we have 2 sets of congruent sides, they're opposite, the legs opposite, those 2 congruent legs must also be congruent. So if we know, that means then that segment AB must be congruent to segment BT because it's an isosceles triangle. So since AB is 2.4, what must be BT? It must also be 2.4. So let's kind of sum up what happened there. So first, we were able to find that angle T, or angle, what would better way to label that would be BTA. We found that angle BTA was equal to 40 degrees. We also found that the angle BAT is also 40 degrees. And that means that triangle ABC must be an isosceles triangle. And based on the patterns that we learned about isosceles triangles, we know that the sides opposite those congruent angles must be congruent as well. And that's how we solve that problem. All right, so that brings us to our key phrase assignment. So here's your key phrase assignment that I've already stated for you. So what you're going to do is you've got 3 parts that you have to answer this week. For the week of October 11th, key phrase assignment. So we learned about the CPCTC postulate this week. So in the so really the number 1 question has to deal with the acronym. Whoops, what did I do here? That's not right. The acronym. So in the acronym, we've got that letter P that stands for parts. Corresponding parts of congruent triangles are, shouldn't have said that. That's giving away part of the answer for part 3. So in this postulate that we learned, the acronym includes the letter P that stands for parts. So what is that? What parts are we referring to when we're talking about parts of a triangle? What are we referring to? And I spoke directly about this in the recording today. And then really, I guess I'm going to skip number 2. Really just then explain to me in your own words. You don't need to do number 2. That's kind of part of number 3. Explain in your own words then what it means, CPCTC. So you do need to complete 1 and 2. You need to complete both questions to get full credit. So you need to answer questions 1 and 2. And if you need a review of how to complete the key phrase assignment, all the directions are below. As always, if you have any questions as you're working this week, please let me know. Have a great rest of your week.